In order to use the trick we've been using, we have to change either the sign in terms of cosine or the cosine in terms of sine. Which one can we do here? Can we change cosine to have sine in it, or can we change sine to have cosine in it? How can we change sine into cosine? That's a good guess. You're supposed to know this, but you may not know this because, right. So, do you remember I showed you what the Pythagorean theorem in terms of trig functions is? It was cosine squared plus sine squared is equal to 1. Because we have cosine, we're able to change this cosine squared in terms of sine. If we get cosine by itself, we get that cosine squared is equal to 1 minus sine squared. All right. Now we have everything in terms of sine. If we rewrite that, we have sine squared theta plus sine. We have to subtract this 2 over because in order to solve quadratics, it has to be set equal to 0. So this is negative sine. And then we have that plus 1 in front, and then this minus 2. If we multiply both sides by negative 1 to get rid of the negative in front of this sine squared, over here before we multiply by negative 1, we have 1 minus 2 is negative 1, so it becomes plus 1. Now let x equal sine theta. That means we have x squared minus x plus 1 equal to 0. Can we factor this? 1 times negative 1 is negative 1. We want a positive. Positive 1 plus positive 1 is positive 2. We want negative 1. Remember, it has to, huh? So this one, it has to multiply to equal 1 and add or subtract to equal negative 1. Kristen, how do you factor this one since you're so good at it? So this cannot be factored. because there are no factors of one that can combine to give you negative one. So if it can't be factored, what can we use? Remember, there are different ways of solving quadratics. Factoring was one of them. There were other methods that we talked about. And I told you two of them always work. Starts with the Q. If we can't factor, we can always use the quadratic formula. What is the quadratic formula? Almost. Yeah, so ax squared plus bx plus c. That means a is 1, b is negative 1, and c is 1. All right, if we plug in a, b, and c, we get negative 1 times negative 1, which is positive 1, plus and minus the square root. Negative 1 squared is 1. Negative 4 times 1 is negative 4. And all divided by 2. So what happens now? Hmm? What is square root of negative 3? You don't need one. We can't take the square root of a negative number. So this one has no solution. No real solution. When we simplify, we are trying to rewrite whatever function we have in terms of sine and cosine and see if anything can cancel out. All right, so let's look at an example. We have cotangent theta divided by cosecant theta. We want to simplify this. How can we rewrite this in terms of sine and cosine? So cotangent is cosine over sine. What about cosecant? Yeah. Cotangent is cosine over sine, and secant is 1 over sine. Now we have a fraction being divided by a fraction. That's the same thing as what? Yeah. What's the reciprocal of 1 over sine? What is cosine theta divided by sine theta times sine theta? Yeah, we multiply across. You just multiply cosine, sine, yeah, theta, yeah. Do you say a little rock? All right, so cotangent divided by cosecant just equals cosine. Any questions on that? All right, next one, we're gonna have to rewrite it. We're given a fraction, so we're gonna have to rewrite it and so that they have a common denominator. We have 1, 1 plus sine theta divided by sine theta plus cotangent minus cosine over cosine. We're trying to simplify it still, but for this one, since we have a fraction, we have to rewrite it so that we have common denominators. Well, we can't really simplify anything right now. Cotangent, the CSC, cosecant. How'd you get that? Not exactly. So we're just trying to rewrite this so that they have common denominators. How do we get common denominators here? We cannot because of this plus sign. We can only cancel we can only cancel things out if everything is being multiplied. So again, how do we get common denominators here? What is the butterfly method? So multiply this side by a sine. You have to do both, top and bottom. And then what about this side? All right. So if we distribute the cosine to this one, we get cosine theta plus sine cosine. What do you mean? We will. Yeah. And then on this side, we have to distribute sine to the cotangent and the cosine. Yep. Yeah. Yeah. So now that they have the same denominators, we can combine them under one fraction. What? You can ask. I'm listening. No, it does not. Since it's being multiplied, you can write it whatever order. Yes, you can. So this is plus sine cosine, and then we're subtracting sine cosine, so they cancel each other out. Yeah. The bottom doesn't do anything yet. Mm-mm. All right. If they have common denominators, we combine it under one. Yeah, it's only squared if we multiply, but we're adding, so we can combine it under one. It's kind of like, yeah. So it's kind of like adding 3 over 2 plus 5 over 2. It does not equal 8 over 4, right? It just equals 8 over 2. The denominator doesn't change. Yeah, so same thing here. All right, what is cotangent in terms of sine and cosine? Yeah. All right, so if we change the cotangent to cosine over sine, what happens? We change this cotangent into cosine over sine. Yeah, yeah, right. So what happens here? You mean these two? Yeah, they can cancel out because it's kind of the same thing that happened on the other page right here. So yeah, the sines cancel out and we're left with cosine theta plus cosine over cosine sine. Yeah. Yeah, it's like adding x plus x. That's 2x, right? We haven't done anything to the bottom yet. We're just simplifying the numerator. All right, now what? Yeah, we can cross out one of the cosines in the numerator and cosine in the denominator. Where'd you get cosine over sine? Yeah, so they're being multiplied. So again, if we add 2x over x, the x's cancel out, right? Leaving the 2. Yeah, so same thing here. What is 2 divided by sine? That's the same thing as 2 times 1 over sine. What is 1 over sine? Cosecant. All right, so yeah, so this whole fraction simplifies down to 2 cosecant theta. All right, so that is simplifying. The next thing we're going to do is proof. We have to prove that the right side of the equation is equal to the left-hand side of the equation. So we're proving that the right-hand side equals the left-hand side. We want to prove that cosecant theta times tangent theta is equal to secant theta. When we do this, we pick one side and try to get it to look like the other side. More times than not, you're going to get the left side to equal the right side. Can we simplify the left-hand side? The best way to approach these kind of problems is to change everything in terms of sine and cosine and see if anything cancels out. The secant. Okay, if we make that 1 over cosine, does that help us any? So let's leave the right-hand side alone and focus on the left-hand side because that looks more complicated than the right-hand side. So let's see if we can simplify that down. Let's change cosecant and tangent in terms of cosine and sine. Right? Okay. So we have 1 over sine times sine over cosine. So again, when we do this, we only pick one side to change. We don't change both sides. Cosecant was equal to 1 over sine. Tangent was equal to sine over cosine. When we multiply the two together, the signs cancel out, and we're left with 1 over cosine. 1 over cosine is secant, which is what we were trying to get to. Yeah, I'm gonna do one more. I know, right? You just might. You just might. All right. This time we have tangent theta plus cotangent theta divided by secant theta times cosecant theta is equal to 1. Yeah. Yeah, we have to make the left side equal 1. We should always start by trying to change it in terms of sine and cosine. Do you mean like cancel these out? We can only cancel if we're multiplying. We can't. In order to add fractions, what do we have to have? Yeah, we have to have common denominators. So there are two ways we can approach this problem. We can either find a way to cancel out all the denominators, or we can find something to multiply to each one of these to get a common denominator. So what do we have to multiply this by to get rid of this denominator? And what do we have to multiply this by to get rid of this denominator? So what if we multiply by cosine sine? And we have, if we do it to the top, we have to do it down here too. Almost. So since we're multiplying into a group with a plus sign, we have to distribute. So if we multiply this fraction by sine over cosine, we get cosine theta, sine times sine is sine squared over cosine. And if we multiply that to this one, cosine times cosine is cosine squared. Same thing, if we multiply sine and cosine to the ones, all right, any questions so far on how we got from here to here? How I how I did the bottom here? Because when we're multiplying, we're only multiplying the numerator. No, not unless this was a fraction. Yeah. Yeah, when we multiply straight across. No. All right. Everyone else good? Whoever else is here. All right. So now that we've multiplied everything, we can cancel stuff out. In this fraction, the cosine cancels out. In this fraction, the sine cancels out. Over here, cosine cancels out, sine cancels out. We're left with sine squared. I made a mistake. This is supposed to be multiplied. All right, so since everything in the denominator is being multiplied, let's see, I will. All right, going back over here. Cosecant is 1 over cosine. Sorry, secant is 1 over cosine, cosecant is 1 over sine, right? When they're being multiplied, we can combine them into one fraction, right? No problem. So 1 over cosine times 1 over sine is the same thing as 1 over sine times cosine. Yeah. All right. So if we multiply this by cosine and sine, what happens? Right. What is cosine sine divided by sine cosine? Yeah, they cancel out. All right, last step. What is sine squared plus cosine squared? Yes, it is 1. So we get that the left-hand side is equal to 1, which is what we're trying to get to. All right, so let me recap because I made a mistake. We still have to change everything in terms of sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. And then down here, everything is being multiplied together. So secant is 1 over sine. Cosecant is 1 over cosine. When we multiply them together, we can put them under one fraction. So that's what happened here. All right. To get rid of all the denominators, to get rid of this denominator, we need to multiply by cosine. To get rid of this denominator, we have to multiply by sine. So to take care of both at the same time, we multiply by cosine times sine. If we do it to the numerator, we have to do it to the denominator. When we multiply the numerator by cosine sine, we get cosine sine squared for the first fraction, and we get cosine squared sine for the second fraction. And then the denominator, since we're multiplying everything, we just multiply straight across. We get cosine times sine divided by sine times cosine. In the numerator, the cosines cancel out from the first fraction. The sines cancel out from the second fraction, and we're left with sine squared plus cosine squared. In the denominator, everything cancels out. The cosine cancels out with cosine, sine cancels out with sine, and we're left with 1. Pythagorean's theorem says sine squared plus cosine squared is equal to 1. So we get 1 divided by 1, which is 1. And that is what we're trying to get to. not for the problems that I give you. Your job will be to make sure that they equal the same thing. So each problem I give you will work out. All right.